In this video, we will be talking about the separators and the fundamentals of its design. Separators are the most widely used equipment in industry. In general, separation mechanism relies on several factors, such as gravity, boiling point, and etc. Considering the project and needed equipment, we will need to know more about a gravity separation and separators. The mechanism for gravity separation is so basic. The components with small density are going up and the denser components are coming down. Generally, the gravity separators are divided into two parts, 2- and 3-phase separators. If the water content is so small or negligible, and there is prediction from oil production facility that the water content will not be high, 2-phase separators are used. However, in case of more water content coming into the feed, or if it is predicted that the water content will be high, it's recommended to use 3-phase separators. Another classification of separators is based on the reservoir source pressure. If the separator comes with atmospheric pressure of between 40 and 60 atmosphere, the used separator is high pressure separator. And for low pressure separator, the operating pressure should be between 10 and 20 atmosphere. The third classification of separators relies on their structure, whether they are horizontal or vertical. The choice between vertical or horizontal vessels depends on the gas-to-liquid ratio and the advantages that one orientation over the other gives to reduce costs generated through the operational problems. Some of the features of vertical vessels will become apparent when the design procedures are reviewed, but it's essential to consider some of the general aspects. First, considering the GOR, which is gas-to-oil ratio, it should be mentioned that where the liquid volume is low or gas volume is so small, horizontal vessels may not be appropriate. Then, the capacity of gas handling is another aspect. As we will see once the design of these vessels, a vertical separator functions the vessel diameter when handling the gas, not level of the liquid. Therefore, the vertical separators are recommended to use when higher gas handling capacity is needed. Pure accessibility. Vertical separators do not provide better accessibility to the safety systems. Due to their height, access to safety systems such as relief valves and controllers will be more difficult, and hence operating costs would be higher than that of horizontal vessels. Another aspect would be about smaller footprint. When compared to horizontal vessels, the physical area occupied by a separator and the additional structural supports will be less than equivalent horizontal vessel. Therefore, the vertical vessels are better to operate in offshore platforms. Turning to the horizontal vessels, they are more economical for normal gas to oil duties, and especially when there is a tendency for the oil to foam. The necessary aspects relating to horizontal separators are as follows. The large horizontal separators provide good surge handling and slugging abilities than small horizontal vessels and, of course, vertical vessels. Then, although the horizontal vessels require more floor area, they are easier to mount in a modular format. For certain applications, processing modules are receiving renewed interest, particularly when anticipated production lifespans are small. And later, the access systems are important, as that for the vertical separators. Because of their height, these separators are easier to access the relief and control systems. The horizontal separators are better to deal with foams that are caused by either bubbles produced by the inlet deflector or by liberation from the bulk oil phase that can reduce the separator's handling capacity. As you have completed the video about separators and their classification, you don't have to forget that there are more to learn. So get refreshed and come back for the next videos.